Now I'm going to move on to data entry and error detection or checking. I'm going to use the Delhi Depot data set from here on when I look at the next two stages of the process. So the easiest way to look at error checking in your error checking process is to run and check the frequencies of all of your items. For the purpose of this video, I'm just going to focus on the Delhi Depot item X1, friendly employees. So this is the basic output for a frequency analysis. So I'll come back and explain how to analyze this in a second. I'll show you how to do it first. So here are the instructions. So when running these frequencies, you do actually have two options in SPSS. You can do frequencies or you can do descriptives. So my Delhi Depot data. So what do I mean by this? So we go to analyze descriptive statistics. So you have two options. You can use frequencies or you can use descriptives. I like to use frequencies because I can get all of the same information, and I can also get a chart of that shows distributions as well, which, being a visual learner, I find it easier to look at. So I'm selecting frequencies, my X1 variable on the left. I then select the arrow so it's now on the right. I click statistics. So this is where in frequencies you can get all of your descriptive statistics as well. So in central tendency, I can get my 3 different central tendency measures: mean, median, and mode. In dispersion, I can just select all of them. I'll talk about them all later. And characterize posterior I assume that's dispersion, but who knows. I select skewness and kurtosis, and I set continue. Then I select charts, and I like the histogram and show normal curve on the histogram, and hit continue and select OK. So SPSS creates an output window. Here are my descriptive statistics. Here are my frequency output, and here is the histogram chart that I have asked it to produce as well. So how do we analyze these for error checking? So here again we have a frequency output if I didn't ask it for statistics. So error checking. The first thing to look for is whether there's missing data. Missing data means that the respondent either didn't respond to this question or the data inputter missed inputting an answer for this question. If this gives you an idea that you need to go back to the original source of the data to see whether there was an actual answer given. But often respondents do miss answering questions unless they are forced to put in an answer. So there are various decisions that need to be made. If there is data missing, what are you going to do? There are two main approaches to missing data. The first is to eliminate the respondent from the data set entirely. So you reduce your sample size by taking this approach. Or a common way of dealing with missing data is to input the mean for the entire series into that cell. The second approach means that you can keep a larger sample size. However, it can create biases when it comes to the analysis. The other thing to look at in terms of missing data is, should there actually be missing responses here? So if you have a skipped question or a skipped question logic within your survey design, as in if someone answers yes to a question, they might be skipped to 3 questions ahead, meaning that there's 3 questions that yes respondents should be missing for. So this is where in the frequency we check to see whether those yes respondents have actually been skipped past the questions that only the no respondents should have been answering. So that is something that's important to check, because particularly in self-completion surveys, people may not be paying enough attention to realise that because they answered yes for question 10, they should be skipped towards question 16, for example. The other thing to do in terms of descriptives is to look at your range of responses. So if the scale is between 1 and 7, the range of responses should be between 1 and 7. And we see for this item, our response range is between 1 and 6, which falls within the parameters of the scale that was used to measure it, so we don't have any respondent or inputting error here. Other error checks that can be done. So I talked about adding those survey IDs or respondent IDs to the top of all of my handwritten surveys. That let me do random checking of originals versus the inputted data. We can do negative question checks. So in the design, I had those questions that were negatively coded. Well, they need to be reverse coded, or they were negatively phrased questions. These can be used to make sure that respondents were paying attention, because if they're giving all positive responses, 4 and 5, to the positively framed questions, then they should be giving responses in the 1s and 2s to the negatively framed questions. Look at the missing data. Like I've already said, you need to either replace with the mean or delete the response from the data set. And finally, you need to document all of the decisions and procedures that you used. For example, if you are using option 2 in your missing data solutions, then you need to report that we received, for example, 100 responses, but 5 surveys were eliminated from the sample due to missing data, giving a final sample size of 95 respondents. This is how these kinds of decisions are reported. Okay, finally, preliminary data analysis. So we're talking about data description here. Who is included in our sample? So this gives indications of the representativeness of the sample versus the population, and gives us a sense of who it is about who we are doing the analysis on. So this includes 3 stages: data tabulation, and looking at measures of central tendency and dispersion. So what we're looking at here, so we've got frequency distributions, measures of central tendency, measures of dispersion, and measures of distribution shape. So stick with me here. So frequency distribution is how far along a scale our respondents lie. Measures of central tendency is how peaky versus flat our respondents tend to sit. Are they all sitting in the middle, or are they ranged along the measurement scale? Measurements of dispersion. Do we have a lot of people at either end? Do we have are people not centered around the mean? Do we have these kind of skewness? And the distribution shape, so this idea of peakness versus flatness. So frequency of distribution, the ordered array of observed variable values and the frequency at which they occur. So I have it in doing my frequency analysis, I have it in 2 forms. I have it in numbered form, where I can look at the percentages, I can look at the counts. So this is the counts of respondents along these measurement scale options. This is the percentage of the sample that sits along these scale options. We can do it by accumulation, that make sure it adds up to 100%. Because I'm visual, I like to look at it in the histogram form. So this, because I got the normal distribution shape, I can look at the actual distribution versus what a normal distribution would look like. And as I can see from this histogram, we have slightly higher than expected people responding at just below what would be a normal mean. So, the measures of central tendency. We have 3 ways of measuring this, and which one you would use depends on the type of data you have. So, the mean is the sum of all observations divided by the number of observations. This is relatively straightforward. It's also called average. It's something that you probably should have been taught in primary school. However, we use the mean to report the central tendencies of our data when we're dealing with interval or ratio data. A median is where we take the value, basically we range our values responses from everyone who said 1 to 2 to 3 to 4 to 5 to 6 to 7. We range it along in one great big long line, and we take the observation that falls smack bang in the middle of that range of responses. So median works best for ordinal data, but it also is used for ranking data, and often you'll hear the median referred to in cases such as house prices, where you might not have that many observations and you might have a large difference between your upper and lower end data. So in this case, the median is 4, whereas the mean was 3.62. So the most, in terms of the range of responses that we had, out of 7, the one that fell in the middle was 4. Mode, on the other hand, is the most frequently occurring value. It can be used for any type of data, but tends to be used for binary or categorical data. In this case, the mode is 3, which is below the mean and also below the median. Modes are most often actually, in terms of males and females, kind of categorical data, often actually reported more in percentages than in counts. So the measures of dispersion. So this is how far along our scale our data is distributed. So the most commonly reported measure of dispersion is the standard deviation, which is the square root of the variance. However, we do have range, which is the largest value minus the smallest. So in this case, the maximum that was reported was 6, the minimum was reported was 1, which gives us a range of 5. So even on a 7-point scale, people might have, everyone might respond 3 or 4, meaning that it's 4 minus 3, giving us a range of 1. So a very, very undispersed data set. Variance is computed by summing the square differences from the mean for all the observations and then dividing by the number of observations minus 1. I know, don't worry about it. Here it is reported right here, 1.764. However, the standard deviation is the square root of the variance, and when we look at the distribution, it tends to be how, in terms of how many respondents fall outside of 1 standard deviation versus 2 standard deviations, so on and so forth. And the coefficient of variation is not produced in SPSS statistics, and it's not necessarily something that we often report. It's just a slightly more sensitive measure of dispersion. So if we look at our histogram, we have our standard deviation of 1.328. So what would that suggest is that we have a slightly more distributed sample than a normal distribution would suggest. So one standard deviation would be 95% of our respondents would fall within one standard deviation, whereas we are 1.328 standard deviations where you'd have 95%. Measures of distribution shape. So this is peakiness versus whether it's skewed one way or the other. So skewness basically is whether our shape is towards the mean, or the peak is towards what a normal mean would be, or whether it's shifted towards the left or right of the mean. So we have our skewness output. So a skew of greater than 0 means that the distribution is skewing slightly to the right of the mean, where a skew of less than 0 skewed negatively to the left of the mean. And kurtosis describes the flatness versus peakiness of the distribution. This has got some funny words here. So leptokurtic, which is the peaky, so pointy, if it's greater than 0, it would suggest that it is more pointy than expected, whereas less than 0 is platykurtic, which I called flatty, so how more like a plane or unhill-like the distribution is. So in this case, it's minus 0.674, so therefore we have a relatively flat kurtosis in terms of distribution. So in terms of this, so we're slightly to the left, as you can see here. It's a bit to the left than a normal kurtosis one. A normal skew, which would be here. We are peaking over here in terms of the dispersion in this case. And kurtosis, the normal suggests that it would be to this point, whereas we are a little bit flatter than expected with our distribution down here. So that is for a single table of our variables. The next thing we can do is a cross-tabulation in terms of descriptive statistics. So this is used to describe the relationship between two categorical variables without testing necessarily for statistical significance between those variables. It is very commonly used in analysis in marketing research projects, especially looking at describing relationships between demographic information and purchase or usage information. So the decisions you need to make with cross-tabulation of what are the categories of variables to be tested, variable selection and any recoding that you might need to do, and what does the outcome mean in terms of the interpretation. So to run a crosstab, again, it's one of the descriptive statistics, and just to be aware that it doesn't actually matter where you put your variable. So it doesn't matter if I put gender as a column or usage as a row, that makes no difference in terms of the analysis. So to show you what this looks like in SPSS, I go back to my Delhi depot data, I go to Analyze, Descriptive Statistics, Crosstabs. So I'm going to put gender in the row and I'm looking at usage in the column. I ignore statistics at this point and I go to cells, and I can select The percentages are some of the most commonly chosen. Often we also add expected, but I'm not going to do that for this purpose. So here is my Crosstab output. As you can see, I have no missing cases. I've got 100% of my data being considered. So how do we analyze this data? So I'm just going to look at within gender outputs. I can then look at within usage outputs and make different interpretations. So if I look at within gender, females, 23% are light users while 76% are heavy users. So the majority of female respondents are heavy users. Looking at male with gender, 65% are light users while only 35% are heavy users. So what does this mean? Well, Deli Depot's highest usage customers are female. So Deli Depot should target females in terms of, for this particular question. If the question is who should Deli Depot target, the answer is Deli Depot should target females. There might be a different research question, which is how can we improve our sales? And the answer there might be we might need to target males to encourage them to use more. But that is a different question with a different interpretation. So just be very careful about how you interpret it. Please also notice that I make no conclusions about why females are higher users than men, and I make no conclusions about why men are light users. I also make no suggestions at this point. The reason I can't make any speculate as to why females and males are different in terms of usage or suggestions for their different using behavior is that further research is required. So either you have collected the data to explain why these differences occur and or collected data to look at what suggestions would be appropriate for these different genders and usage types, but until you analyze that data, you can make no further conclusion than what I have stated here. So this is the end of the lecture on how to input your data, how to run your initial checks on your data, and also do your initial data analysis in describing your sample.